Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0112, refers to an issue with the intake air temperature IAT sensor 1, where the circuit is detecting a low voltage signal. The IAT sensor is responsible for measuring the temperature of the air entering the engine, and it works with the Powertrain Control Module, PCM, to optimize engine performance. When the voltage output from this sensor falls below a specific threshold, it triggers the PCM to store the P0112 code, indicating a defect. The sensor is typically located in close proximity to the mass airflow (MAF) sensor within the intake manifold area. Accurate readings from the IAT sensor are crucial for ensuring fuel efficiency and proper engine combustion. Therefore, resolving issues related to this code is essential for vehicle performance and compliance with emission standards. The DTC P0112 signifies a malfunction in the IAT sensor 1 circuit, specifically characterized by a voltage output that is markedly low. The IAT sensor plays a pivotal role in air intake management. It gauges the temperature of air entering the engine, a critical function for the PCM's ability to adjust fuel mixtures appropriately. The sensor is commonly mounted near the MAF sensor, making it integral for the intake system. This location ensures that the IAT sensor gets accurate data about the incoming air temperature. A failure in this sensor can lead to incorrect air-fuel ratios, potentially causing performance degradation and exacerbated emissions. The circuit itself functions by sending voltage signals to the PCM, and when these signals are lower than the expected threshold, the DTC is generated, prompting further investigation. Several factors may lead to the occurrence of DTC P0112. First, a faulty IAT sensor is a primary suspect, as its purpose directly influences the readings that the PCM relies upon. Second, wiring issues could compromise the communication between the IAT sensor and the PCM. For instance, shorted wires can alter the signal transmission. Third, there is the possibility of an underlying PCM malfunction. If the PCM does not process the incoming signals correctly due to internal faults, it could misrepresent the values, leading to inaccurate diagnostics. By assessing each potential cause systematically, technicians can accurately identify the root of the problem. Additionally, checking the connector integrity and wiring harnesses for damage or disconnections forms a crucial part of the investigation process. Identifying symptoms associated with DTC P0112 can significantly aid in the troubleshooting process. Firstly, vehicle operators may notice poor engine performance, characterized by hesitation or reduced power output, stemming from incorrect air-fuel ratios. Secondly, an increase in fuel consumption is common, as the engine may struggle to optimize its efficiency without accurate input from the IAT sensor. Lastly, the most apparent symptom is the illumination of the check engine light on the dashboard, signaling to the driver that a diagnostic code has been triggered. Observing these symptoms can streamline the diagnosis and indicate to technicians where to focus their troubleshooting efforts. Understanding these indicators is vital for addressing the issue promptly and preventing further complications. The first troubleshooting step for DTC P0112 is to turn the vehicle's ignition to the on mode without starting the engine. This action allows the vehicle's diagnostic system to activate, including the IAT sensor. Next, the technician should connect the Honda Diagnostic System, HDS, to check the voltage output from the IAT sensor 1. If the voltage is measured at less than 0.08 volts, it confirms the presence of the failure indicated by DTC P0112. This step is critical as it verifies whether there is indeed an issue with the sensor's output. Accurate measurement and interpretation of this data point will guide the technician in further steps. If the voltage is above 0.08 volts, this may indicate the sensor or related components could be functioning correctly, warranting further investigation into wiring or PCM health. In this step, the technician inspects the MAF sensor and IAT sensor 1 for any faults. This involves examining the sensor and its wiring for any signs of damage or degradation. If the sensor's output is found to be below the normal threshold during the previous step, the technician should disconnect the MAF sensor IAT sensor 1 connector to evaluate its functionality more closely. Conducting further checks on the internal workings of the sensor can isolate issues such as dirt accumulation or internal shorts. If the sensor is confirmed to be faulty or providing consistently low readings, replacement should be considered to restore proper air measurement functionality. Accurate diagnosis at this juncture is crucial, as it can either solidify a major part replacement or prompt further inspections into other components associated with the air intake system. Next, the technician performs an inspection of the external circuit connected to the IAT sensor. This involves checking for potential shorted wires or broken connections that might cause the sensor to produce a low voltage signal. It is recommended to first disconnect the PCM connector before testing, ensuring safety and preventing inadvertent faults during the process. The technician should use recommended methods outlined in the open shorted wire inspection description to evaluate the integrity of the wiring harness. Specifically, when checking the ITA1 circuit for shorts to ground, ensuring that resistance levels remain above 1 megaohm is crucial. If abnormalities are detected in the wiring, repairs or replacements should be administered to rectify the circuit integrity. Confirming a sound electrical pathway is essential for restoring proper IAT sensor function and eliminating this DTC. If prior inspections of both the IAT sensor and external circuit yield normal results, the next step is to inspect the powertrain control module, PCM. The PCM can be a common culprit when diagnosing electronic failures, as it processes and interprets signals from various engine components. To conduct this inspection, technicians should evaluate the PCM for any signs of internal faults or software irregularities. Utilizing diagnostic tools like the HDS can help reveal any stored errors in the PCM or aid in verifying its signaling capabilities. Should it be determined that the PCM is at fault due to abnormal behaviors or errors, replacement or reprogramming may be required. It is essential for technicians to confirm this scenario with rigorous checks, as replacing the PCM is often a significant undertaking and should be carried out only when deeming necessary. After completing the troubleshooting process for DTC P0112 and performing necessary repairs, it is crucial to undertake final repair verification steps. Begin by clearing all diagnostic trouble codes using the HDS, which resets the vehicle's monitoring systems. This is important as it allows the PCM to reinitialize and accurately track any newly occurring faults. Subsequently, it is essential to verify the functionality of the IAT sensor, ensuring it provides accurate readings under different operating conditions. The technician should turn the ignition back to the on position while monitoring the IAT sensor values. Observing steady and correct voltage outputs without triggering the DTC will confirm that the repair was successful. This verification assures that the vehicle can monitor its air temperature effectively, preventing any further issues in engine performance or emissions. To prevent future occurrences of DTC P0112, adopting a regimen of preventive maintenance is advisable. Regular inspection of the IAT sensor and its wiring can help catch any signs of deterioration before they lead to functional failures. Additionally, ensuring that the air intake system remains clean can significantly impact sensor performance. Dirt or debris may obstruct airflow, leading to inaccurate readings. Routine checks of the MAF sensor in conjunction with the IAT sensor can provide a comprehensive overview of air intake health. Furthermore, changing air filters according to the manufacturer's recommendations plays a pivotal role in keeping the intake system clean and free from obstructions. By committing to these preventive measures, vehicle owners can enhance the longevity of their sensors, reduce the likelihood of DTCs, and maintain optimal engine performance. In conclusion, successfully diagnosing and resolving DTC P0112 involves a systematic approach that includes understanding the role of the intake air temperature sensor, assessing the circuit, and verifying PCM functionality. Regular monitoring of the IAT sensor health, alongside addressing potential wiring issues promptly, is key to sustaining vehicle performance. Furthermore, recognizing the symptoms of sensor failure, including poor engine performance and increased fuel consumption, empowers drivers to take proactive measures. Adhering to recommended preventive maintenance practices will enhance sensor longevity and foster better engine efficiency. Overall, a comprehensive understanding of DTC P0112 and its implications can significantly contribute to a smoother, more reliable driving experience. Please like and subscribe to the channel. See you next time.